If you watch a video of a teacup falling off a table and shattering on the floor, you know instantly if the video is playing forward or backward. Welcome to This Explainer, where we are exploring one of the most profound, deeply atmospheric mysteries in all of physics, the arrow of time. We're going to look at why things break, why they never seem to unbreak, and what that tells us about the very fabric of reality.
A cup can fall and break, but those broken pieces, they don't spontaneously leap back together. This everyday reality reveals something absolutely fundamental. At human scale, time undeniably has a direction. The past feels fixed. The future feels open.
Now, what's really interesting about this slide is the stark contrast it highlights. Because when we zoom all the way down to the fundamental laws of physics, something strange happens. A paradox emerges. Many of the equations we use to describe particles, fields, and motion are time reversal symmetric. A simple macroscopic collision can look completely mathematically valid whether the clock runs forward or backward.
Which brings us to a rather massive question. If the macroscopic rules allow reversibility, so why does the macroscopic world become a one-way street? Why doesn't the teacup simply reverse its physics and rebuild itself right in front of our eyes?
Section 1. The standard picture. Let's look at the established framework we use to understand this one-way street.
The standard answer in physics is, of course, entropy. It's the idea that the arrow of time emerges because systems have a natural, mathematical tendency to move from rare, highly specific configurations toward overwhelmingly more numerous, dispersed configurations.
As we can see here, there are very few microscopic arrangements that correspond to a perfect whole teacup. It requires immense localized specificity. But for a shattered teacup, there are vastly more arrangements. We're talking about dispersed heat trails, sound waves, dust, and microscopic motion spreading outward into the room. This brings us to a crucial realization. The teacup breaks because there are many ways to be broken and very few ways to be whole. It's not a magical force. It is a sheer statistical inevitability. Now, general emergence mechanics, or GEM, doesn't reject this standard thermodynamic view. Instead, it gives entropy a beautiful geometric interpretation. Entropy is not merely chaos. It is relaxation into configurations the total system can more easily maintain. A shattered teacup is a state where energy, heat, and structural information have relaxed, dispersing into a wider admissibility basin.
Section 2. The Coherence cost hill. Let's move to this next concept and see how this builds our understanding. In GEM, every configuration carries a coherence cost. A stable structure must keep its internal geometry strictly organized. Imagine an intact teacup as a highly specific, localized peak on a geometric landscape. It takes effort and a high structural cost to maintain that precise peak. When the cup shatters, that concentrated structure dissolves into a flowing, lower-cost basin. The structural cost is no longer concentrated in one precise object. Instead, it dynamically spreads across the environment into fragments, heat, sound, and air motion. The system has rolled down the coherence cost hill.
Which leads us to the pivotal realization of this entire explainer. The cup does not unshatter because the return path is too expensive. To reassemble, the scattered energy would have to somehow climb all the way back up that steep, narrow peak of localized structure.
Section 3. Scattered structure. Let's look at the sheer physical magnitude of what a time reversal would actually demand.
If we wanted the teacup to spontaneously rebuild, the system would need an astronomically precise convergence of energy, momentum, phase, heat, vibration, and molecular arrangement. Every single fragment, every trace of heat fluctuation, every microscopic motion would have to coordinate and flow backward in perfect unison.
Now, it's absolutely crucial to understand this. Reversal is not forbidden by a supernatural rule. It is overwhelmingly inadmissible without an external organizing boundary. Physics doesn't ban the teacup from reforming. It just lacks the organizing walls required to force the entire dispersed environment backward, up that steep coherence cost hill.
To put it as simply as possible, rebuilding the teacup would require the whole room to collaborate. The sheer scale of coordination required renders it functionally impossible in our macroscopic world.
Section 4. Time as relaxation.
In this sweeping philosophical view, time isn't a hidden clock ticking in the background. Time is the visible direction of global field relaxation and the signature of constraint resolution. It is the visible sequence of a system settling its internal constraints toward a lower total coherence cost. And this brilliantly illustrates how this exact same logic scales universally across completely different physical systems. In 1 second, a teacup breaks because stress disperses. In 1 hour, a hot object cools as heat spreads. Over a day, a cell must repair to resist disorder. Over 1 billion years, a star radiates light to relax its gradients. And over a millennium, a civilization collapses when accumulated coherence debt overwhelms recovery.
Across all these incredible scales of reality, there's one core rule of persistence. The universe does not keep every possible arrangement. It keeps what can continue paying the cost of being itself. Only that which can afford the geometric cost remains coherent under disturbance.
Which brings us to a deeply profound conclusion. Time is not a dimension we are being dragged through. It is the universe learning how to settle. The arrow of time is simply the direction in which relaxation becomes more available.
I'll leave you with this final, completely mesmerizing thought to ponder. Do we move through time, or do we watch the geometry of reality resolve?